Alright, so I think this is recording. We're taking a look at skill packet 5, exponential functions and log functions, and this was our test over that. And here on these 6 problems, we're looking at the graphs of log functions. We know from our basic library of functions that if you have a log, that the basic graph, it is the logarithms and the exponential functions are inverses of each other, and our graph of a basic log has a shape like this, where the exponential function had a y-intercept of 1. When you have an inverse, you switch the domain of range, so now that y-intercept is now an x-intercept of 1, and the domain of the exponential function was all real numbers, so the range of a logarithm is all real numbers. And for the basic exponential function, the range was positive real numbers, and that's the domain for a basic logarithm, is positive real numbers. And the horizontal asymptote of a exponential function, y equals 0, becomes a vertical asymptote of a log function, and we write the equation as x equals 0. So let's see if we can match these equations to this graph. Log base 8 of x is going to have this basic shape, but I see that we also have a log base 2 of x, which is going to have a similar shape. So for this log base 8 of x, what if we allowed x to be 8? What would the y value be? So if we have log base 8 of 8, 8 to the first power is equal to 8, so this is just the number 1. So I know that this graph is going to pass through the point 8, 1. So the two possibilities that I see that have that basic log shape are 8 and m. But here at 8, I can see, well, I can't see it very well. It looks like it's 3. It looks like this point is 8, 3. And I'm wanting to have my graph pass through the point 8, 8, 1. So this guy is m. Alright, now the difference between 9 and 10 is a reflection. So it's a reflection of this graph of m, and the reflection is across the x-axis. So I'm looking for something that has that general shape, and there it is in H, that H and M are reflections of each other across the x-axis. This plus 2 is a shift to the left 2 units, and then a reflection across the x-axis. So if I go to the left 2 units, I'm going to be here, and then if I reflect that across the x-axis, I have, where did it go? Right there in J, looks to be that one, right? Alright, now the negative in the interior is a reflection across the y-axis for this m, and across the y-axis, it's going to be something like that, which, here it's 1. I should have, by freehanding it, it's hard to see. The reflection across the y-axis, if this is 1, 0, it's now negative 1, 0. And it's going like that, so it's L log base 2. Well, the bigger the base, the more that it's hugging this x-axis. When I see a base of 2, if I look at a point on the graph that, out here when it was 8, I know that 2 to the third power is 8. So that's how I know that this is passing through 8, 3. And so there's my 8, 3. And it also had the x-intercept of 1. So this is G. And when I look at 14, I can see that we already have it in 10 right there, that the log base 8, that 1 over x, I can write that as x over 1 to the negative first power. And by the power rule, that negative sign comes out in front. And I see that that was the number 10, so 14 and 10 have the same graph because they're just the same equations written differently using properties of logarithms. So I hope that helps in those 4, and I'll talk to you later, or those 4, those 6, and I'll talk to you later.